Okay, so let's look at the second half of the assignment from 2.2.2. Again, this was a little bit longer section and was divided into two different nights. So this is the homework from the second night. And it starts with question 63. It says, explain what the slope of each line below represents, then determine the slope and give its unit. So this first one, the slope of this line is the height of a candle uh, over time. And it looks like this is either it's an electric candle that's using batteries or a magic candle, but it looks like the height of this candle is not changing. It's always about 20, 21, 22 centimeters tall. So if I was going to give the slope of this one, well, because my change in y is always 0, right? You can see the y is not, it's not going up or down. So because it's not moving up or down, the change in y is 0. Change in x is kind of immaterial, right? I could pick any interval I want. Let's just say that we're looking at the change of x from here to here, which is 2. Well, that ratio, right, 0 divided by 2 is 0. This is a horizontal line. Horizontal lines do have slopes, and they have slopes that equal 0. It also says determine the units, right? So the units of this slope are centimeters per minute. M-I-N-U-T-E. So the units of this are centimeters per minute. And you can see I'm taking the centimeters from the y-axis, the change in y, and the minutes is time. That's from the x-axis. All right, on part B, it says that we have a water storage tank, and the units are given as gallons, and the time there is months. And the first thing that they ask, it says, explain what the slope of each line below represents. Well, I would say that this is the rate of change in the amount of water in the water tank, right? And we can see that it does start at month 0 with 9,000 gallons, and at the end of 10 months it's down to 0 gallons remaining. So if I was going to calculate the slope, I could say that my change in y, I end up at 0, right? And I started at 9,000. So that's how much y changes. My change in x, I started out at month 0, and I end up at, wait a minute, let's get this right. This point is the point 0, 9,000. This is the point 10, 0. Yes. So I end up at 0 gallons, and I started at 9,000. So I take this and I subtract this one. And then for I wrote delta y again. For my change in x, x ends up at 10 months, right? But I started at month 0. So my change in y is negative 9,000. My change in x is negative 10. Well, positive 10, right? 10 minus 0 is 10. So I'm left with a slope of negative 900. And the units for that are gallons per month. So we're consuming, or this tank is being depleted by 900 gallons every month. All right, let's move on to question 64. 64 gives me 2 points, and it says calculate the slope of the line that goes through these 2 points. All right, I think we kind of just did that on the previous problem. Let's try it again. So again, we're going to be looking at our y values, and we're going to calculate the change in the y's. And for this problem, my y value ends at, I'm going to say that arbitrarily I'm going this direction, right? I'm just going to say that I end up at 10 for y, and I started at 70. So there's my change in y. For my change in x, I'm going to go the same direction. My x value ends at 5, and I started at negative 15. So I've got 5 minus where I began, negative 15. So again, when I find the difference of these, it's always a subtraction problem, and realize that you could end up subtracting, in this case, subtracting a negative 15. So that changes things a bit, right? My numerator now is positive 10 minus 70, which is negative 60. And my denominator is 5 minus negative 15, which is positive 20. Um, 20 goes into 60 evenly, right? It goes in 3 times, and because it's negative, I could say that my unit rate here, my slope would be negative 3 over 1. So I might just write the slope is negative 3. So when I write that, when you see a slope without a denominator, right, the implicit denominator is 1. So we're looking at a unit rate here, right? It's going down 3 every single time x increases by 1. All right, so that's question number 64. 65. We're given different versions of the function f of x, right? Each one of these has a different function, but they're all being given the same name. And what we're supposed to do is calculate the output for each of these functions when negative 3 is the input. So if I look at the first one, right, this one, f of negative 3, negative 3 goes in, it's going to be negative 2 rather, times negative 3, and then plus 3. So every single place that I see an x written down, right, when I see the x written down, we're just going to sub in our input value. So you can say I placed a negative 3 there. Negative 2 times negative 3 is 6, and 6 plus 3 is 9. So my output for that first function f, my output when the input is negative 3 is 9. So negative 3 goes in, 9 comes out. Next function, this would just simply be 4 to the negative third. And we do understand that we're not particularly fond of negative exponents, so I could just write this as 1 over 4 to the third. And 4 times 4 is 16, and 16 times another 4, I believe, is 64. So that 4 to the third power is simply going to be 1 over 64. So for this second form there, for part B, when f of x is 4 raised to the x power, I end up getting 1/64th when negative 3 goes in. All right, next value, c. This looks complicated. So I'm being very careful to use parentheses for my input. So I've got negative 3. I'm raising that to the negative second power and then adding 1. So the first thing I want to do is clean up this negative exponent. So this is going to be rewritten as 1 over negative 3 to the positive second power plus 1. This is, I'm squaring negative 3 here, so I'm going to have 1 over negative 3 times negative 3, which is 1/9. And I'm going to turn the number 1 into 9/9. So you can see I've got a 9th, and I'm adding 1 more to it, which is 9/9, and I get the answer 10/9. And you could write 1 and 1/9, but really this is a preferred answer. I have 10/9. So for C, when negative 3 is the input into that function, the output is positive 10/9. And then the last question for D, my function is 1/2. Again, the input each time is negative 3. And when 1/2 goes in there, that's going to become a negative 3/2, right? 1/2 times negative 3 is negative 3/2. And then plus, I'm going to write this 2 as 4/2, because certainly I can multiply 2 by the number 1, right? 2 over 2. So 4/2 is equivalent to 2. And when I combine negative 3/2 and positive 4/2, I've got exactly 1/2. Negative 3/2 plus 4/2 is positive 1/2. So for D, when negative 3 goes into that function, 1/2 is the output. Let's move on to question 66. For 66, it says Greta is opening a savings account. She starts with $100 and plans to add $50 each week. What is the unit rate change for this situation? Okay, so the unit rate would be $50 per 1 week. So it's a unit rate when this number in the denominator is 1. So $50 per week is the unit rate. And then it says write an equation Greta can use to calculate the money she will have after any number of weeks. How much money will she have after 1 year? Okay, so let's see. The equation y, the number of dollars, would equal $50 going in each week plus she started with $100 in the account. So this is x is given in x needs to be given in weeks for this equation, because remember this unit rate is dollars per week. So if I want to know what the answer is for a year, I need to convert that year into weeks, and I think it's 52. I don't know why I think that. So yeah, it's a little bit more, but it's approximately 52 weeks. So I'm going to write this down. This is kind of a giant one. 1 year is the same thing as 52 weeks. So I have 52 weeks. I'm going to plug 52 in for x, and I definitely want a calculator for that. So I'm going to grab it and go 52 times 50 plus 100. So if she kept up the $50 each week, this account balance y should be $2,700 after 1 year. So you have the equation here. I should write a sentence. She will have dollar symbol $2,700. Right, let's move on to 67. It says, review what you know about graphs by answering the following questions. What is the equation of the line graphed at right? Alright, so let's look closely at it. From this equation, I can see pretty clearly a change in y of -2. Let's be careful. Yeah, 1, 2. It went down -2 units there, and it went over a change in 1 unit. So I'm just peeking at the units here. Each one of these lines is 1, right? So I don't have to worry about getting this wrong. So my change in y, my delta y is down 2, and my change in x is 1. So the slope of this line is -2 over 1. And my y-intercept occurs at 1, right? Y-intercept is at 1. So I think the question, what was it? It says, what is the equation of the line graphed at right? So the equation of this line should be y equals -2x and then plus 1. And then the other thing it says is what are the x and the y-intercepts for this line? So, you know, when I know the equation of the line, if I want to find the x-intercept, basically I need to let y equal 0. So if I let y equal 0 in that equation, I get 0 is equal to -2x plus 1. I'll take away, I'll subtract 2x from both sides, right? Things are equal, I add equal things to both sides. So I'm adding positive 2x to both sides. So this gives me 2x over here, and this side becomes 1. Again, I just added 2x to both sides. And now I'm going to divide both sides by 2, so I get x is 1/2. So my x-intercept has to be at the point x is 1/2 and y is 0. That's my x-intercept. My y-intercept, when I want to find the y-intercept, that's when I'm going to let, I will let x equal 0. And when I let x equal 0 in that equation, it becomes y equals -2 times 0 plus 1. So y is 1. So that means my y-intercept is x was 0 and y was 1. So I can see here is my x-intercept, here is my y-intercept. And you can see how I found this. This is a pretty easy case because the equation was relatively nice and I could just look at the graph and see that. But if it's more complicated, I really recommend remembering if you're finding the x-intercept, let y be 0, and if you're finding the y-intercept, let x be 0. And I believe that is the last question. So keep up the good work. I will see you in class tomorrow.